Sir?
Yeah, okay. 1 minute. Just load பண்றேன். Okay. Right. So audio video clear இருக்கா? திரும்ப disconnect ஆக மாட்டீங்களா? Right now. So we'll continue. The last class we have discussed about the resistance and the content எல்லாம் பார்த்தோம். So we'll see. So here today we are going to discuss about few topics. And now first நான் content சொல்லிடுறேன். After that we'll discuss. And உங்க doubts ஏதாவது இருந்தா we'll discuss at the end. So we'll see the contents. Today we are going to discuss about the drift velocity. Drift velocity. Before discussing about the drift velocity, first of all, we'll discuss about the current. Current are two types. One is your electronic current and one is your conventional current. Conventional current and the electronic current we'll discuss that. Okay, and after that we'll discuss about the drift velocity, and after that we'll discuss about the relation between electric current and drift velocity. Electric current and drift velocity. Okay, and after that we'll discuss about the relation with respect to your resistivity. So either on the from this relation, from this electronic current and drift velocity, we are going to deduce the relation for Ohm's law. So V is equal to I. We are going to derive it. And after that, we'll see the relation with respect to your resistivity also from this same relation. And after that, we'll see the relation for J, sigma, and E. So the relation between J, sigma, and E, we call it as a macro. Okay, so we'll discuss it then. So there are two types of Ohm's laws are there: macroscope and microscope. And so we'll discuss that one also. Macro and micro. Macroscope and microscope, the Ohm's laws. So other than in a relation, we'll discuss it. And after that, we'll discuss about your coefficient of resistivity. The term is alpha. We call it as coefficient of resistivity. So the relation is R2 is equal to R1 into 1 plus alpha delta. We'll see the relation. And after that, we'll see the unit for alpha also and what will happen with respect to different materials. And after that, we'll see your KCL and KVL. So here we'll discuss about the Kirchhoff's voltage law and as well as Kirchhoff's current law. So in middle also, we'll discuss about the mobility also. So these are the things we'll discuss here. And these are the ரொம்ப important terms. So the drift velocity relation, conventional current and the electronic current and your drift velocity relation, and after that KCL and KVL. So after that, at the end of these contents, we are going to do some problems. One by one. So first of all, we'll discuss about the current. So what is current? Current na enadu? Charges. Right. So what I'll do, I'll take a small example. A small example and we'll discuss one. Okay. So when we are discussing about this one, so here in this case, I have a conductor. So assuming I'm just taking a conductor, which in a conductor. So for this conductor, I'll connect a voltage. Voltage na connect. So in this voltage, so now the current flow in the voltage. So the current is flowing in this direction from positive terminal to the negative terminal. This is your voltage. And in the conductor, it has its own resistive property. The resistance that is your opposing flux charges. So in this case, current on the flow in the direction current flow from positive towards the negative. Okay, when positive towards the negative, the current we call it as conventional current. We call it as conventional current. So that means the protons are traveling the same direction to the current. Positive charges are traveling the same direction to the current. Positive charges traveling same direction and this current we call it as conventional current. CONVEN, and right here it's a conventional current. CION, conventional current. This is your conventional current. And remember one more thing. So when we are discussing about the current direction, this opposite to the flow of electrons will be there. So the flow of electrons will be there in opposite direction. That means they'll be having some free electrons. These free electrons are traveling from negative towards the positive in opposite direction. Okay, opposite direction of the electrons of the flow. These electrons are your free electrons. Free electrons. And this current, the flow of electrons, this current we call it as electronic current. We call it as electronic current. Electronic current. Okay, and either the length of the conductor I'll take this L. Length of the conductor I'll take this L. And this or area. So either a relation that we are going to discuss in later class. Okay, either on the conventional current. So protons are traveling in the direction from positive towards the negative. That current we call as conventional current. Opposite to that, free electrons are traveling from negative towards the positive. So that current we call as electronic current. Conventional current and electronic. And remember, when we are discussing about the supply current is nothing but your conventional current. Remember, whatever the supply current we are discussing from positive towards the negative from the voltage, the supply current we call it as electronic conventional current. Supply current is nothing but your convention. Okay. So let's see. So in the relation memorize panikonga, we'll discuss this relation. Idukku oru chinna derivation irukku. We'll discuss that. But before this one, we'll try to understand your drift velocity. We'll try to understand your drift velocity. Let's see that. Same example. So for that, what I'll do, I'll take a conductor. I'll take a conductor. So the conductor la enna panniterukena, so they'll be having some charges passing from negative towards the positive. So let's see. So it is your voltage, இது positive terminal, இது negative terminal. இதுல வந்து current flow ஆயிட்டு இருக்கு. Current எந்த direction flow ஆயிட்டு இருக்கு? From positive terminal to negative terminal, in the direction current flow ஆயிட்டு இருக்கு. As usual, this current is nothing but your conventional current and which is your supply current. Okay. So here, in this case, there will be a free electrons. Free electrons and slippery electrons and சொல்லலாம். These slippery electrons are always traveling from negative towards the positive. இதனால negative வந்து towards the positive attract ஆகும். Okay. So in the direction இது flow ஆகும். These are your free electrons. The free electrons we call as slippery electrons னு சொல்லலாம். Slippery electrons னு சொல்றோம். So we call it as a free electrons னு சொல்லலாம். Okay. So when the electrons are traveling from negative towards the positive in the opposite direction to the current direction travel it. So here when it is traveling opposite to the current direction, so when we are discussing about the current, இது வந்து ஒரு electric field இருக்கும், flow of charges. So this is your electric field direction. Remember, electric field directions always நம்ம வந்து positive towards the negative தான electric field directions travel இருக்கு. This is your electric field direction, and this conductor it has its own length. I'll take the length of the conductor and இதோட area வந்து I'll take this A. Okay, let's see that. So these electrons we call as free electrons and slippery electrons னு சொல்றோம். When these are slippery from negative towards the positive, it has its own velocity. Okay, so that slippery electrons it has its own velocity. This velocity we call it as a drift velocity. We call it as a drift velocity. And remember, we are discussing about the electrons only. So electrons are the negative charge particles. Okay, so electron is your negative charge. We are discussing about the negative charge particle. Okay, remember it. Let's see. So when the electrons are traveling from negative towards the positive, what will happen? It has its own force acting on it, and either electric field and it has its own mass. Let's see. So we know that when the electrons are traveling from negative towards the positive, so we know that the force F is equal to QE. ஏன்னா வந்து இது electric field தான் electrons வந்து move ஆயிருக்கு. Okay. And when we are discussing about the force, charge and சொல்லும்போது இது negative charge particle. I'll take force F is equal to minus electric field E into your electron. F is equal to minus small e into capital. So I'll take this one as first equation. Now, so when we're discussing about the charge particle, it has its own acceleration as well. We know that velocity is equal to, or acceleration is equal to your velocity divided by the time period. Acceleration is equal to velocity divided by time period. And as well as acceleration is equal to force by mass. There is one more relation. So here, what I'll do, I'm going to substitute in this relation. Acceleration is equal to force divided by mass. So force is nothing but minus electric field into your charge divided by its mass. The acceleration A is equal to minus E by M. Okay, so I'll take this one as your second equation. Now we need to find the drift velocity. So on the electrons go drift velocity, I'm going to substitute this second equation in your acceleration is equal to velocity by time. So when you do substitute, so velocity is equal to acceleration into the tau. Tau we call it as relaxation time. We call it as relaxation time. So let's see the relations. So in this case, when the acceleration, when you're substituting, the velocity is equal to, it is a minus electric field E, okay, and the electron divided by its mass and the total time. So V is equal to minus E by M into, okay, and either the unit as usual, it is nothing but your meter per second. Remember this relation. This is your velocity with which the electrons are traveling. Okay, so this VD, I'll take it as VD. VD is your drift velocity. It is your drift velocity. Okay, it is your drift velocity. Okay, remember this case. Now, so when we're discussing about the drift velocity, adala relaxation time, the electrons may can travel. It is not traveling in a straight line. It may can travel in different directions. Different directions, negative and the positive travel. Adara average time we are taking it as relaxation time. Okay, so this average time between the collisions and with the wall and as well as the electron. I'll write here itself. The relaxation time is nothing but your average time between two successive collisions or between two collisions. Okay, between two collisions within the electrons. Okay, and as well as with the wall. Okay, this is your drift velocity. Okay, remember this technique. There are relation ரொம்ப important. Sure.
Yes, sir.
Right. So let's see next. So next one, we'll discuss about your current. Let's see the relations. Go to the next page. So next one is your relation between electric current and drift velocity. The relation between electric current and drift velocity. Electric current and drift velocity. Let's see the relations. Same example. இதுக்கு முன்னாடி எடுத்த example தான். So assume there is a conductor. Conductor இருக்கு. So for this conductor, there will be electrons are traveling from negative towards the positive, and in the conductor I am connecting a voltage. Like this is your V, this is your plus, this is your minus, and this is your current direction. This current we call it as your conventional current. This is your conventional current. 1 minute. One. So in the conventional current, the opposite direction, the electrons will be traveling. So this is your electrons which are traveling in opposite direction to the current. So here we are going to discuss about this current and as well as the drift velocity of the electrons. Let's see the length of the conductor. I'll take a set. Take the length of the conductor. So and the area of the conductor is A. And so here the total electric field, the electric field length will be traveling from positive towards the negative. This is your electric field direction. Okay, and it is opposite to your charges. Okay, so and the length of the conductor ELL கொடுத்திருக்கு, and remember when we are discussing about the conductor, and there will be potential difference between these two. The potential difference at the ends is nothing but your V. We know the relation electric field to potential to ஒரு relation இருக்கு. Electric field E is equal to V divided by L. நம்ம வந்து first chapter discuss பண்ணிருக்கோம், second chapter discuss பண்ணிருக்கோம். E is equal to V by L. Remember it. Electric field E is equal to the potential difference and divided by the length of the conductor. Now, so in this case, so for this volume of the conductor, there are n number of electrons are traveling. The n number of electrons are traveling in per volume. Let's see that. So the number of electrons per unit volume, number of electrons per unit volume, I'll take this small n. So that means there will be number of electrons are traveling depends upon its own volume. So I'll take the small n. So small n, I'll take it as your electron density also. I'll take this electron density also. Okay, small n is nothing but your electron density. And we know the charge of electron is charge of electron is E. So the number of electrons is there and charges of electrons are there. Now when we're discussing about the number of electrons in length of the conductor, so when we're discussing about the number of electrons traveling the conductor, I'll take this capital N. So capital N is a number of electrons. So when we're discussing about the capital N number of electrons, earlier we told you that now small n is nothing but your number of electrons per unit volume. So small n into its volume of the conductor. Remember the number of electrons is nothing but small n into the volume of the conductor. So when you discuss about the volume of the conductor, it has its own area and it has its own length. So I'll take the relation as your small n into A into the length of the conductor. I'll take this one as first equation. Okay, remember. So when we are discussing about the total charge connected in the length of the conductor, so here the total charge, so it's nothing but your Q is equal to, depends upon the length of the conductor. So Q is equal to N E A into N. Remember the charge and its volume. So charge and its volume is nothing but your Q. So here this is your total length of the conductor. We got Q. And we need to find the current. So current is nothing but I is equal to your Q divided by T. Q we got it, and we need to find the time period. So time period, it directly depends upon your drift velocity with which it is taking traveling from negative towards the positive. So the time period I'll take it as T is equal to the distance divided by your drift velocity. Distance traveled divided by drift velocity. So distance is nothing but your length of the conductor L divided by B. I'm going to substitute the relation here. So Q is nothing but your N times E A into L divided by the different drift velocity, that is your time period is nothing but L by B. LL will get cancelled. So I is equal to N E A B T. This is your current with which the electrons are traveling. Let's take it. The current relation is important. Nalita, is it work? Doubt here? Okay. Let's see your current density. So here we got the current. That current is nothing but your current is the current with which the electrons are traveling. Now we'll see about your current density relation. Current density. Current density. So the relation, the symbol for current density is J. J is equal to I by A. Remember, J is equal to I by A. So let's see. So I value we already know. I formula we already know. I is equal to N E A V. I'm going to substitute the relation in this equation. So here N times your electron area of the conductor and your drift velocity divided by the area. Areas will get cancelled here. So J is equal to N times EVD is your current density. The unit for current density is nothing but your ampere meter power minus 2, or we can say ampere per meter square. Remember it. This is your current density. Okay. Now here we got the current density, and the current density on the, because there is a direction, it is your vector quantity. I'll write in vector form also. J is a vector quantity, and it is equal to N times electron is your scalar into your drift velocity is your vector quantity. So this is your vector form, your current density. Okay. Now let's see the deduction of your Ohm's law from these relations. Okay, either the doubt here, current density. Or
Yes, sir.
yes, ma'am. Good. Let's see next one. So next case, we are going to deduce the Ohm's law from this relation. Deduction of Ohm's law. Deduction of Ohm's law from this relation. So in this case, so here we already know across the conductor there is a potential difference. Across the conductor there is a potential difference, and we know that the length of the conductor L, and there is an electric field E passing from positive towards the negative. So that means we, when we are relating this one, electric field E is equal to V by L. We already know this relation. Now let's see. So here the drift velocity, the relation is Vd is equal to E capital E by M into tau. This is your relaxation time as well. So instead of electric field, what I'll do, I'm going to substitute the potential difference, because the relation itself, it is your Ohm's law. The electric field placed on the potential na substitute. So the relation will be E. So E is equal to V by L. So V divided by mass into L into your tau. Okay, this is your drift velocity. I'll take this one as first equation. And here we already know the conductor, it has its own area, the number of electrons are traveling. So the current I is equal to your E N A into BD, which we derived it earlier. So I'll take this one as second equation. Substitute first in second equation. So the relation will be I is equal to N E A, BD is equal to E B by M into L into tau. So here E will be multiplied, it is N E square. So N times E square A B by M L into tau. This is your current. So this is your relation. So what I'll do from this relation, I'm going to convert into in terms of V by I. Ohm's law na convert பண்றேன். So here this is your V and this is your I. So VI ஒரு side நான் எடுத்துக்கிறேன், மற்ற terms எல்லாம் I'll shift to other side. So here M into L divided by N E square A into tau is equal to V by I. Let's see that M into L by N E square A into tau is equal to V by I. V by I is nothing but your Ohm's law. This is nothing but your resistance. Voltage by current is your resistance. So it is M by L divided by N E square A into tau. Okay, so this is your deduction of Ohm's law from this relationship. So we can say V by I is constant, which is equal to your resistance R. Okay, and you already know there is a formula for resistivity. R is equal to rho L by A and so to a formula number discuss where rho is your resistivity. Rho is your resistivity. So from these two relations, I'll take this one as your third equation, I'll take this one as fourth equation. By comparing these two relations, there is a term called resistivity. So let's see that. The resistivity, the term is rho when you're comparing. L constant, A constant. So here rho comparing it, so it is rho is equal to M by N E square tau. Rho is equal to M by N E square tau. This rho we call it as resistivity. Okay, please take it. By comparing these two relations, we can get it. So if you see that the rho, whatever the resistivity we have discussed, it depends upon two things. Rho depends upon two things. One, the number of electrons depends upon two things. One, number of electrons, and the second one, the relaxation time. The relaxation time. So remember the number of electrons in the resistivity depends and as well as the relaxation time resistivity depends. Okay, please take this relation. And then the boxes put these relations are.
Yes, sir.
Okay, good one. Right, let's see next one. Next one, the relation between your current density, your conductivity, and electric field. The relation between current density J, conductivity sigma, and electric field E. Electric field E. So let's see. So here in this case, we know that the electron is nothing but your negative electron. So Q is nothing but your minus E. We are discussing this negative electron only. And drift velocity Vd is equal to minus E, capital E, tau divided by M. This is your drift velocity. So now we are going to find your current density. Current density relation on the J vector, because these are your vector quantities. J is your vector quantity. And electric field vector quantity because they are having some direction. Let's see. J is equal to, it is N times a Q into your drift velocity V vector, which is equal to. So Q is nothing but your N times of minus E because your negative charge particle, and into drift velocity is minus E tau divided by M. So I'll take everything in vector quantities. So this is your vector. So let's see that. So minus minus will get cancelled. So J is equal to, it is N times E square tau divided by your mass into your electric field E vector. Okay, please take it. J is equal to N E square tau by M into E vector. So from this relation, what I'll do, we now already know resistivity ko formula நம்ம இதுக்கு முன்னாடி discuss பண்ணிருக்கோம். Resistivity rho is equal to is M by N E square tau. resistivity இது முன்னாடி நம்ம டிஸ்கஸ் பண்ணது rho is equal to m by n square tau. Okay, or I can take it as in terms of your conductivity. So conductivity is sigma. Sigma is equal to 1 by rho. Remember, conductivity and resistivity both are inversely proportional. This is your conductivity. Okay, so which is equal to n e square tau divided by m. N e square tau divided by tau. So I'm going to substitute the ratio. So which is equal to n e square tau divided by m is equal to sigma. So this is your electric field. So here J vector is equal to sigma into E vector, or I'll take this E vector is equal to rho into J vector. Let's take this relation.
Yes, sir.
Okay, good one. Let's see next one. Next one we call as mobility of a charge carrier. Mobility of a charge carrier. Let's see. So the mobility symbol on the mu. Remember, mobility symbol on the mu. There are definitions in it. I'll write here itself. So here, definition on the mobility of a charge carrier, it is nothing but your drift velocity acquired by it in a uniform electric field. Let's see, I'll write here itself. The mobility of a charge carrier is the drift velocity acquired by it in a unit electric field. So remember, so there is a mobility of charge carrier, the movement of charge carriers. So it is nothing but your drift velocity, which it is acquired in your electric field. So we already seen the relation. The electric field E is equal to V by L. Similar to that. So here electric field and your drift velocity, we call as mobility mu is equal to Vd by E. Remember, mu is equal to Vd by E. This is your mobility of charge carriers. So as a drift velocity, we know that drift velocity relation is a Vd is equal to your Q. I'll take it as charge. I didn't say the electron. I'll take it as charge. Electric field tau divided by m. This is your drift velocity. So from this relation, we can say, so your mu is equal to your Q E tau by m divided by your Vd, that is your electric field E. It is your E. So in the electric field will get cancelled. So the relation is a Q tau divided by m. This is your mobility. So when we're discussing about the mobility, இது வந்து total charge base பண்ண discuss பண்றோம். Suppose mobility of electrons, mobility of protons, that means holes இருக்கும்போது the relations will be like this. So here I assume the mobility of electrons, which is mu e, which is equal to your charge, your relaxation time for the electrons divided by mass of electron. Same thing, mobility of holes. Mobility of holes is nothing but your protons. I'll take this mu h is equal to your E tau h divided by mh. Okay, electrons for holes here. Okay, remember it. So let's see the unit for this mobility. So first of all, drift velocity வந்து we already know drift velocity இங்க வந்து meter per second னு சொல்லிருக்கோம். இங்க வந்து electric field வந்து V by L னு சொல்லிருக்கேன். So I'm going to write here. So mu ஓட unit part. So drift velocity unit is nothing but your meter second inverse divided by electric field வந்து நான் potential divided by the meter, that is V by L னு சொல்லிட்டு நான் consider. So what I'll do, I'll reverse it. When I do reverse it, the relation will be, it is a meter square. Remember, V will be reversed, V inverse S power minus 1. So it is a meter. Okay, this is your potential difference and it is your time. Seconds. Okay, this is your area. M square V inverse S power minus 1 is your mobility. Please take it. Or suppose if you want to find the conversions, MKs to CGS conversion பண்ணும்போது நீங்க meters வந்து centimeter convert பண்ணா and potential வந்து same ஆ இருக்கு. Potential, that is your voltage, it won't change. So the unit in terms of your CGS. So CGS in terms of your CGS is nothing but your centimeter square. It is a V inverse S power minus 1. And when you do the conversion, so that is MKs to CGS, 1 meter square V inverse second power minus 1 is equal to 10 power 4 centimeter square V inverse S power minus 1. Without doubt in the kernel.
So what is mu h?
Each one, which one?
Mu h.
Mu h is holes, ma proton idu. நம்ம வந்து protons வந்து we'll consider it as holes. Protons, positive charge particle. Electrons வந்து negative charge particle. Protons தான் நம்ம வந்து holes ன்னு சொல்லிட்டு consider பண்ணுவோம். Over, ma?
Yes.
Okay, good. Now, their relations, we are going to relate with respect to your current. Mobility with respect to current path. And the relations are very important. Let's see, next one. So here, a relation between electric current and mobility of a conductor. Relation between electric current and mobility of a conductor. So what are the relations I'm discussing here? In their relations, உங்களுக்கு வந்து semiconductors last chapter class 12th வரும். அந்த டாபிக்ல வந்து திரும்பி இதே ரிலேஷன்ஸ் அங்கே லிங்க் ஆகும். ஓகே, லெட்ஸ் see. Relation between electric current and mobility. So இங்க வந்து current relation வந்து we already know I is equal to NEA VD and சொல்லிட்டு ஒரு relation நம்ம already discuss பண்ணிருக்கோம் for the conductor. It has its own area, it has its own length of the conductor. There will be electrons traveling from negative towards the positive. We already know it. And we know that mobility relation mu is equal to VD by E. I'll take this one as second relation. Or I'll write in terms of your VD. So VD is equal to mu times your electric field E. I'm going to substitute this relation in the first one. So current I is equal to NEA VD, which is equal to VD. Now substitute panna, it is N times EA U electric field. This is your relation between your mobility and current. Okay. Now, so idhula vandu current relations enakku. So what I'll do when we are discussing about the electronic current in terms of your semiconductors. Idu vandu conductor, mobility of conductor. அதே semiconductors வரும்போது இது வந்து partially conductor ஆகும், partially insulator ஆகும். So that means அதுல வந்து semiconductorல வந்து charges வந்து holes and electrons split ஆகும். So here when we are discussing about the semiconductor, இந்த டாபிக் வந்து electronic devices last chapter நம்ம டிஸ்கஸ் பண்றோம். So here when we are discussing about the current, இதுல வந்து two types of current இருக்கு. One வந்து electric current and one is your hole current. So இதோட காம்பினேஷன் தான் total current flow ஆயிட்டு இருக்கும் under semiconductor. இது வந்து intrinsic semiconductor சொல்லிட்டு நம்ம டிஸ்கஸ் பண்றோம். We call it as a pure form of semiconductor. Okay, let's see. So இதோட electronic current சொல்லும்போது same current, it is NEA. So for electronic current சொல்லும்போது I'll take it as mu E. Okay, so I'll take it as mu E and plus it is for this holes and சொல்லும்போது it is E, it is N, I'll take it as proton P. Okay, mu H. Okay, remove it into A. So here the electronic current and your hole current. Idura rendu combination there. Okay. So Ne is the electron, this is the proton. So mu H is your holes mobility, mu E on the electric mobility. So idula on the what I'll do, electric field, this on the charges on the same irkum. So I'll take E itself. So area constant irkum and electric field constant irkum. I'll remove it. So EA into electric field and the number of holes, number of electrons mattum change agum with respect to its mobility. So N times mu E plus N times mu H. This is your total current flowing through the semiconductors. இந்த ரிலேஷன்ஸ் எல்லாம் ஈஸி தாமா, நீங்க வந்து மக் பண்ற மாதிரி எதுவுமே இருக்காது. அந்த சீக்வன்ஸ்ல தான் நான் வந்து கொடுக்குறேன் உங்களுக்கு. Just remember it. So உங்களுக்கு drift velocity and the convection current relation தெரிஞ்சாலே you can able to remember all that. Don't mug it up. The relations and the units ரொம்ப important.
சார் E வந்து மைனஸ் எலக்ட்ரான்ஸ் வந்து மைனஸ்
இல்லம்மா நான் வந்து எல்லாமே பாசிட்டிவ்ல தான் கன்சிடர் பண்றேன் in terms of your current. சார்ஜ் பத்தி நான் டிஸ்கஸ் பண்ணும்போது நெகட்டிவ் and positive. When I discussing about the current, I will take it as electron. Number of holes, number of electrons, current is the okay. So this E is nothing but your charge of an electron. It is 1.6 into 10 power minus 19. Now, the charge of an electron, charge of photon. Two same.
Yes, sir.
Let's see next one. Okay. Next one is your conductivity. Conductivity of a semiconductor. Conductivity of a semiconductor. It's in a relation. After that, we'll see your KCL. Conductivity of a semiconductor. Conductivity of a semiconductor. Good. So let's see the relations part one by one. So the current from the Ohm's law, V is equal to I into R. So we know that I is equal to V divided by R. And when we're discussing about the conductivity, so it is related to a resistivity, reciprocal of resistivity. So I'll substitute the relation. R is equal to rho L divided by A. So I'll take the relations VA by rho into L. Okay. And we know that V by L is nothing but your electric field. So where E is equal to V by L, I'm going to substitute the relation as, so electric field E into area divided by the resistivity rho. I'll take this one as first equation. Okay, so this is your current. Current ku, electric field ku, area ku, resistivity ku, this is your relation. Remember, நீங்க வந்து questions வரும்போது, problems வரும்போது, you have to create the relations. அப்போதான் you can able to solve the sums. அந்த மாதிரி தான் இருக்குமா. Please do remember, எல்லா relations இங்கே important தான். Okay, மக் எதுவுமே பண்ணாதீங்க. And earlier we know the current I is equal to, it is EA electric field into N times your mu E plus your N times mu H also. Okay, remember it. So here I'll take this one as second equation. Now I'm going to compare these two. When I do compare, the relation EA divided by rho, comparing 1 and 2, which is equal to EA capital E into N times mu E plus N times mu H. So in this case, so area will get cancelled, AA will get cancelled, and electric field will get cancelled. So and 1 by rho is nothing but your resistivity. Rho is your resistivity. Now the conductivity convert, which is equal to sigma. Sigma is equal to E into N times mu E plus N times mu H. Okay. So please take this relation. And either a unit உங்களுக்கு already தெரியும், mobility ஓட unit same தான். It is m square V inverse. Please take it.
So how sigma?
Yes, ma'am. What?
Sigma.
1 by rho. Rho on the resistivity. Okay. Which is
Sigma
equal to
is
sigma.
conductivity.
Conductivity, yes.
Okay.
Conductivity. Okay. That's conductivity. Reciprocal. Other reverse பண்ணும்போது இதோட யூனிட் ரிவர்ஸ் ஆயிடும். ரெசிஸ்டிவிட்டியோட யூனிட் வந்து ஓம் மீட்டர். கண்டக்டிவிட்டி யூனிட் வந்து ஓம் மீட்டர் இன்வர்ஸ் ஆர் மோர் ரிவர்ஸ் வரும். மோ மீட்டர் இன்வர்ஸ் MHO MHO meter. Please. Okay, good. Let's see next one. Next one. So we'll see your temperature dependent. Temperature dependence of resistivity. This is the coefficient of resistivity and solid or term. Let's see the conditions. Next one. So next one, temperature dependence of resistor. Temperature dependence of a resistivity. Dependence of resistivity. So in this case, so temperature dependence of resistivity and so on, I'll take the resistivity relation. We know that rho is equal to this m by n e square, the relaxation time tau. Rho is equal to m by n e square tau. This is your resistivity. We already know. And for the metals, remember for the metals, the resistivity value on the increase depends upon the your temperature increases. So there is a small term here. We'll discuss. So ஒரு சின்ன relation என்னன்னா, so here I'll chin example about. Assume I'm just taking a resistor. Assume I'm just taking a resistor. The symbol for resistor I'll draw it here. So this is your resistor R. Okay, this is your resistor. In the resistance at initial temperature, I'll take it at initial temperature. Initial temperature without any voltage, current flow பண்றதுக்கு முன்னாடி, I'll take the resistance as R0. I'll take the resistance as R0. And இதோட temperature I'll take as T0. Remember the resistance R0 at the temperature T1. So இதோட resistance I'll take it a carbon element. Carbon element it is made up of carbon. For example, so what I'll do, I'll add this resistor to a voltage. When I connect it to a voltage, what will happen? The current will be flowing through the resistor. Current to flow it. When the current is flow, current is nothing but your flow of charges. Flow of charges flow at continuous. When the charges are flowing, there'll be opposing forces. So now it is nothing but your resistor is nothing but your opposing. Okay, it will try to oppose the flow of charges. When it is trying to oppose the flow of charges, what will happen? So this resistor element may can heat up. It may can heat up. Okay, so heating losses will be there. But in the heating losses, we are going to discuss about the temperature and as well as its own resistance. What I'll do, I'll take the resistance as R1 after heating. And either a temperature there is R1, I'll take the temperature T1. Okay, there is a small relation here. In the relation that directly depends upon the material. Depends upon the material and its temperature. And its temperature. Let's see that. So the relation part. So here the relation you can consider in terms of your resistor, you can consider in terms of your resistivity also. The relation it is rho is equal to that. And one more thing, on the resistivity it increases. Remember, resistivity increases in terms of your temperature. So resistivity increase agum, temperature increase agum. Remember it. And what will happen when temperature increases? Conductivity decrease agum. The relation to memorize. Now from this case, so we can take the resistivity rho 1. Rho 1 is nothing but a resistivity after temperature rise. Rho 1 is equal to rho naught into 1 plus alpha into T1 minus T0. We can consider the case in terms of your resistivity, that is your rho naught, or we can consider in terms of resistance also. R1 is equal to R naught into 1 plus alpha T1 minus T0. T1 is your rising temperature, T0 is your initial temperature. I'll write here itself. R0 is your initial resistance. R1 is your rising temperature. Rising temperature resistance. So T0 is your initial temperature. And T1 is your final temperature. That is your rising temperature. Okay, so everything depends upon the material. So where alpha we call it as your coefficient of resistivity, or we can say alpha is your temperature coefficient of resistivity. We'll see the relation for alpha from this case. So alpha is equal to, now the resistivity in article, alpha is equal to, if you want, you can consider this one. So now the step by step and move from there, it will be easy for you. So what I'll do, I'll take this relation. So R rho 1 minus rho naught is equal to rho naught into alpha into T minus T1. T1 minus T0 and consider. So here 1 plus irukku, so it will be shifted towards the left side of the minus side. So what I'll do from this ratio, I'm going to find alpha. So alpha is equal to, in this case, so alpha is equal to, I'm going to divide the resistivity rho naught denominator. So here rho 1 minus rho naught divided by rho naught into T1 minus T0. Or I can rewrite the relation in terms of the resistor. So R1 minus R0 by R naught into T1 minus T naught. Okay, remember this relation. So this is your coefficient of resistivity. And இதோட யூனிட் பார்க்கலாம். யூனிட் பார்க்கும்போது ரெசிஸ்டன்ஸோட யூனிட் வந்து அது டிஃபரன்ஸ் இருந்தாலும் யூனிட் சேமா தான் இருக்கு. It is ohms divided by R naught again ohms and temperature it is your degree Celsius. What will happen? Ohms will get cancelled. So the centigrade degree Celsius will be reversed. So degree Celsius inverse is a unit for your coefficient of resistivity alpha. Remember, without doubt in the thing.
Yes, sir.
Okay, right. That's the next one. So next one. So when we're discussing about the different materials, alpha directly depends upon different materials. So alpha for metals and so on, alpha is positive. Always remember, alpha is positive for metals. Okay, ஒரு சின்ன graph ஒன்னு பார்க்கலாம். Depends upon your materials, that is your copper and nickel. Copper க்கு nickel க்கு ஒரு relation, ஒரு சின்ன graph. Nickel க்கு ஒரு சின்ன graph. Okay. So let's see. So I'll take x-axis and as well as y-axis. X-axis I'll take it as temperature under Kelvin, and y-axis I'll take it as resistivity. So it is your temperature. I'll take this in Kelvin, and y-axis is your resistivity rho. Resistivity rho. So here first case is your resistivity of copper with temperature. It is your resistivity of copper. With the temperature. Let's see the cases. So what I'll do, I'll raise the temperature. So temperature எப்படி raise பண்றேன்னா, it is varying from the zero. So continuously raise. Okay. So but இங்க வந்து காப்பருக்கு எப்படி இருக்கும்னா, so it will be varying from the zero and it will be increasing actually. Continuous temperature raise பண்ணும்போது இதோட resistivity increase ஆகும். This is for your copper. Okay. So this is your graph for copper. And same thing when we are discussing about the nichrome, it is initially there will be having some temperature. When we are raising in temperature, other graph linear fashion increase. I'll take different color. So this indicates your nichrome. So this material will be nichrome. Okay, this is a second case, resistivity of nichrome with temperature. So and the alpha value depends upon the metals தான் இருக்கும். So அது alpha value it is in degree Celsius inverse. Remember it. Depends upon the material, metal, so alpha values varies. So it directly depends upon your temperature and as well as your resistance. ஒரு சின்ன example தான்.
For non-metals, the alpha will be negative.
What one?
So for metals, the alpha is positive, sir.
Metals, non-metals நம்மளுக்கு current flow பண்ணாத இதாகும், அது மெல்ட் ஆயிடும்ல almost heatingல. Non-metals ன்னு சொல்லும்போது ஒரே ஒரு இருக்கு non-metals, but still it is a conductor, that is your graphite. Okay, apart from that எல்லாமே உங்களுக்கு non-metals எல்லாமே அது insulators தான். அதுல current flow ஆகாது, resistance இருக்கும் but current flow ஆகாது. கரெக்ட்டா? Normal. Let's take it. Yeah. Okay, so இதுக்கு மேல stretch பண்ணப்போ, so these are the things which you have seen. So today we have seen your drift velocity, ஒரு part discuss பண்ணிருக்கோம், and after that we have seen the current, and after that we deduce the relation with respect to your current voltage velocity based on resistance, that is your resistivity, Ohm's law, and after that we have seen the relation J sigma E, and after that we have seen the relation with the mobility, and mobility ku electric current ku, and after that conductivity ku semiconductor relation, and temperature resistivity, and we have seen some examples with the graph. Okay, so these are the things. Now, so next one on the or chinna relation number paakalam. After that I'll stop it. So you already know about the series and parallel connection, correct? So in
Yes.
terms of series and parallel connection, so if it is an easy solvable circuit, we can able to solve it. Suppose if it is a difficult circuit, which we cannot able to solve it, so for those circuits, we have to use Kirchhoff's current law and as well as Kirchhoff's voltage law. Rendu laws நம்ம use பண்ணோம். So next class we are doing the problems for these cases. First we'll discuss about the Kirchhoff's current law and voltage law. So before that, let's see the resistance. Resistance in series. What is the formula for resistance in series?
R1 plus R2 plus.
Yes, ma'am. So R equivalent is equal to, it is R1 plus R2 and so on. Same thing when we are discussing about the resistance in parallel, it is a reciprocal. So that is 1 by R equivalent is equal to, it is a 1 by R1 plus 1 by R2 and so on. Okay, this is your resistance which is connected in parallel. Okay, these are the two things, right? So now, when you're discussing about the series and parallel, suppose it is a solvable circuit, so easy circuits, we can able to find the equivalent resistors, and we can able to find the current, we can able to find the voltages also. But if it is a difficult circuit, so which we cannot able to find the equivalent resistance, and the மாதிரி case we have to use Kirchhoff's current law and as well as Kirchhoff's voltage law. Okay, so let's see the conditions. இதுக்கு வந்து ஒரு சின்ன examples பார்க்கலாம், and as well as we'll do some circuits also.
Sir, only for difficult.
Yes ma, yes ma, we'll do some problems. உங்களுக்கே தெரிஞ்சிரும். நம்ம problem solve பண்ணும்போது, so should we use direct relations or should we use your current resistance? And remember one more thing. So circuit கொடுத்துட்டாங்கன்னா, so we need to find voltages also, and we need to find the currents also some cases. Each individual branch current voltage நான் find out பண்ணணும். So when you do the regular method, series and parallel சொல்லும்போது, shortcuts are there, but it will take more time to solve it. So அந்த மாதிரி cases we are taking the KVL. Loop law ன்னு சொல்றோம். KVL is nothing but your loop law. Okay, KCL is nothing but your junction law ன்னு சொல்றோம். Junction law. Okay, so or we can say node law also. Node law also. And KVL related to your series connection. Somewhat series connection. KVL related to series, KCL related to your parallel connection. Remember, KVL on the series, இது வந்து loop law சொல்றோம், KCL வந்து parallel connection க்கு junction law, node law. So let's see one by one. So ஒரு சின்ன circuit நான் எடுத்துக்கிறேன். I'm just taking a small example. So KCL is full form நான் சொல்றேன். Kirchhoff's current law, Kirchhoff's voltage law. Remember, KCL, KVL na Kirchhoff's current law and Kirchhoff's voltage law. Okay, remember it. So when you're discussing about the Kirchhoff's current law, first of all, நான் என்ன பண்றேன், ஒரு சின்ன circuit நான் draw பண்றேன். ஒரு circuit. So there are different resistors are connected to it. I'll take this one as R1. At this point, there are connections, there are different connections like this. Okay, so like this. So these are connected to the points. And this circuit is connected to voltage. Like this. This is your voltage. This is plus terminal, positive terminal, negative terminal. Positive terminal is the bigger terminal, negative terminal is the smaller terminal. So for this case, current to flow out. The current flow out from the positive terminal to the negative terminal. This is your current. Positive and the negative continuous flow out. Okay, so positive and the negative. So for the resistance R1, I'll take this one as R2, I'll take this one as R3, I'll take this one as R4, I'll take this one as R5. So it is nothing but your parallel circuit. Parallel circuit எப்படி சொல்றோம்னா, when we allow the current எப்படி divide ஆயிடுறப்போ, current division based பண்ணி தான் series and parallel நம்ம சொல்றோம். So let's see. So in the R1 branch ன்னு சொல்றோம். This is nothing but your branch. I'll take it as a branch. Branch ன்னு சொல்லலாம், or I'll take sometimes as path. So R1 path தான் current flow ஆயிட்டு. This is your current I. At this point is nothing but your junction. Junction ன்னு சொல்லலாம், இல்லைன்னா node ன்னு சொல்லலாம். Junction or node. Okay, at this junction, what will happen? Current will be dividing. Current எப்படி divide ஆயிட்டிருக்குன்னா, so it will be dividing. I'll take this one as I2. So here இது I1 எடுத்துக்கிறேன். I'll take this one as I2, I3, I4, and I5. So from this junction, so I1 is divided into 4 different currents. So from the junction law or the loop law or the KCL, so I1 is equal to I2 plus I3 plus I4 plus I5. உங்களுக்கு தெரிஞ்சதுதான், right? Same thing I'll write in terms of your KCL statement. KCL statement என்னன்னா, sum of entering currents is equal to your sum of leaving currents. Sum of entering currents is equal to your sum of leaving currents. Remember, sum of entering currents is equal to your sum of leaving currents. So ஒரு junction or node கிட்ட different branches இருக்கலாம். எத்தனை number of branches வேணும்னு இருக்கலாம். Okay, so let's see the currents here. So I'll take this one as I1, I'll take this one as I2, leaving வந்து I3, I4, I5, I6. So at this junction, entering currents is equal to leaving currents, summation. So இங்க வந்து entering வந்து I1 and I2. So I1 plus I2 is equal to leaving currents I3, I4, I5, I6. So I3 plus I4, I5 plus I6. This is your leaving currents. So R, sum of all the currents is equal to 0. So that means I1 plus I2 minus I3 minus I4 minus I5 minus I6 is equal to 0. Okay, so sum of all the currents is equal to 0 or entering currents is equal to leaving currents. This is your Kirchhoff's current law. This is your KCL. So in the circuit law, you series and parallel identify பண்றதுக்கு you have to use this KCL. Okay, current identification, current path பத்தி நம்ம identify பண்றது KCL. Okay, இதுல ஏதாவது டவுட் இருந்தா கேளுங்க. ஜஸ்ட் நம்ம வந்து கரண்ட் பாஸ் பண்ணிட்டு இருக்கோம், அதுல ஒரு ஜங்ஷன் கிட்ட கரண்ட் எப்படி டிவைட் ஆயிட்டு இருக்கு, we have to identify. That's it. கிளியரா? இதுல ஏதாவது டவுட் இருந்தா கேளுங்க.
minus I3 minus I4.
இது மைனஸ் சம்மேஷன் தான் சொல்றோம். இது வந்து நான் ரைட் சைடு இருக்குல, I'm going to shift towards your left side. என்ன ஆகும்? எல்லாமே மைனஸ் தானே. Or I can write the relation as so I1 plus I2 plus of minus I3. சொல்லமா என்ன opposite direction, கரெக்ட்டா? Plus of minus I4, okay, and plus of minus I5 plus of minus I6 is equal to 0. Or sum of all the currents, that is I is equal to 1 to n. Summation நான் கொடுக்கிறேன். In is equal to 0. This is your case here. Okay, நம்ம சர்க்யூட்ஸ் பார்க்கும்போது, சர்க்யூட் சால்வ் பண்ணும்போது இன்னும் டீடைலா நம்ம பார்க்கலாம்.
Yes, sir.
Right? Okay, good. So let's see next. So we'll discuss about the KVL. So KVL வந்து ரொம்ப important. நான் வந்து காம்ப்ளெக்ஸ் சர்க்யூட் பத்தி நான் டிஸ்கஸ் பண்ணும்போது பண்றேன்னு சொன்னேன். So let's see KVL. Kirchhoff's voltage law ன்னு சொல்றோம். Kirchhoff's voltage law. So KVL or we can say loop law. So இந்த KVL நான் வந்து சால்வ் பண்ணனும்னா ஒரு காம்ப்ளெக்ஸ் சர்க்யூட் இருந்தா தான் நான் சால்வ் பண்ண முடியும்னு சொல்லிருக்கேன். So இந்த ஒரு நான் என்ன பண்றேன்னா வீஸ்டோன் பிரிட்ஜ் நான் போயிருக்க சர்க்யூட் உங்களுக்கு we remember வீஸ்டோன் பிரிட்ஜ் ஸ்கூல்ல சொல்லிருக்காங்க.
diamond shape
right, super good. So what I'll do, I'll take the diamond shape. ஒரு சின்ன எக்ஸாம்பிள் பேஸ் பண்ணி நம்ம போலாம். Okay, so I'll take that நான் வந்து வீஸ்டோன் பிரிட்ஜ் நான் சொல்லல because வீஸ்டோன் பிரிட்ஜ் we haven't discussed. So I'll take a diamond shaped structured ஒரு circuit. So இதுல resistance இருக்கும், the resistance will be connected in each branch. These are your resistance. வீஸ்டோன் பிரிட்ஜ் நான் சொல்லவே இல்லைன்னா we are discussing your this one case KVL, that's it. Okay, so here this is your connection and இங்க வந்து ஒரு resistor இருக்கும். I'll take a resistor. Okay, I'll take the resistance as R1, R2, R3, R4 and R5. There are 5 resistors are there in this circuit. So here I'm connecting a voltage across this and சொல்றேன். The terminals I'll take like this. I'll take this terminal as A point, I'll take this terminal as B point. Let's see. இது terminal A, இது terminal B. So across this terminal நான் என்ன பண்றேன், ஒரு voltage connect பண்றேன். So I'm just connecting a voltage. This is your positive terminal, and this is your negative terminal. Okay, so right. So in the mari circuit ku nalla parunga inda circuit ku can we able to find the equivalent resistance? So, is it possible to find the equivalent resistance? Enakku question enna I need to find the total current passing through the circuit and I need to find the branch currents. Branch currents na find it pananum in the question la. In the circuit lo I need to find the total current and I need to find the branch current. Is it possible to find the resistance first of all? Equivalent resistance find it panna mudiyuma idhula?
No, sir.
Why not? ஒரு காம்ப்ளெக்ஸா இருக்கு. I don't know from where I had to start. First of all, practically பார்க்கும்போது I don't know from where I have to start. So first of all, I'll check it. KCL நான் அப்ளை பண்றேன். KCL நான் அப்ளை பண்ணிட்டு current directions எப்படி இருக்குன்னு நான் பார்க்கறேன். So this is your I current. இந்த ஜங்ஷன்ல current I1, I2 டிவைட் ஆயிட்டு இருக்கு. இந்த ஜங்ஷன்ல again வந்து current டிவைட் ஆயிட்டு இருக்கு. I'll take it as I3 and I4. இந்த ஜங்ஷன்ல வந்து என்ன ஆயிட்டு இருக்கு? I2, I3 ஆட் ஆயிட்டு இருக்கு. Here I5 வருது. Okay, இந்த ஜங்ஷன்ல வந்து சேம் current ஆட் ஆயிட்டு இருக்கு. I4, I5 ஆட் ஆயிட்டு இருக்கு. Current I வருது. This is your path, but எல்லாமே டிஃபரெண்டா இருக்கு. பட் ஐ cannot able to take in parallel connection. ஏன்னா வந்து ஸ்டார்டிங் எண்டிங் வந்து இருக்கு, பட் மிடில் வந்து it is a complex circuit. So for that I have to apply KVL laws. Loops நான் யூஸ் பண்ணிட்டு, so with the help of loops I have to solve the circuit. Okay, equation solve பண்ணிட்டு, then I can able to find the branch currents. Let's see one by one. இதுக்கு first of all ஒரு basic condition இருக்கு. ஒரே ஒரு condition தான். Rules வேற. First condition என்னன்னா it has to satisfy the condition. Okay, ஒரே ஒரு condition என்னன்னா, so the circuit should be a closed circuit. Circuit should be a closed circuit. Remember it. Is it a closed circuit?
Yes.
How can you say that?
The two sides are closed. Sorry, the four sides are closed.
Current is starting from one point and it is returning back to the same point and it makes a loops here, correct? Continuously on the divide ஆயிட்டு இருக்கு, அங்கே again it is returning back, correct? It makes a loop here. It is a closed circuit and எங்க வந்து ஓபன் கிடையாது. ஓபன் இருந்தா என்ன ஆகும்? current வந்து zero ஆயிடும். So it is a closed circuit. Okay, now let's see rules பார்க்கலாம். Okay, rules in the sense there are 4 rules are there. Okay, and when we are discussing the rules we have to take the loop. What is a loop, ma? Loop and so when you are starting at one point it is returning back to the same point, shows your loop, right? So it is your loop. So in your loops on we can take clockwise or anti-clockwise. Remember, loops can be taken in clockwise or anti-clockwise. Both are same only. Clockwise or anti-clockwise, both are same only. Remember it. Clockwise or anti-clockwise, both are same only. Let's see. So rules on the 4 rules and so 4 rules are important. This is the simple. Let's see. First one, suppose if the voltage, first we'll start with your voltage. So here this is your voltage. With the plus terminal, is the minus terminal. Okay. So if the voltage V, voltage current direction it is travel from positive towards the negative. Positive terminal and the negative terminal. If the voltage current and the loop direction both are in opposite. Current direction loop both are in opposite. Then voltage is negative. Remember, loop direction, current direction, both are in opposite. So voltage is negative. Second point, if the voltage current and the loop current both are in same direction. Remember, voltage current and the loop current both are in same direction, like this. Voltage current and the loop both are in same direction, so it is positive. Now the loop வந்து எங்க எடுக்கறோம்? closed circuit ல இருக்கும்போது தான் நான் loop எடுக்கணும். Okay, அது first condition. Rules என்னன்னா loop current base பண்ணி தான் நான் வந்து consider பண்றேன். So loop direction current opposite ல இருந்தா negative. Loop direction current same ஆ இருந்தா positive. These are the 2 rules. Let's see the third rule. Third rule வந்து we'll take the resistor. So this is your resistor. Okay, R. Okay, and idhula vandu current I am assuming current in the direction irukku. Okay, current in the direction irukku. Okay, remember current in the direction irukumbodhu loop direction current direction rendu same ah irundha this is your positive. This is your loop. Okay, so positive nala I'll take this IR. And நான் இதுவரைக்கும் வந்து KVL னா எப்படி இருக்கும் அதெல்லாம் வந்து நான் டிஸ்கஸ் பண்ணல. ஃபர்ஸ்ட் நான் ரூல்ஸ் கொடுத்துட்டு then I'll discuss. So both are in same direction, Allah, it is positive. Remember here, just take it. Same direction is in the positive. Same direction in the positive. Opposite direction in the negative. Okay, let's see the fourth rule. Last one. So here I'll take the resistor. A resistor R and இதோட current direction வந்து இந்த direction இருக்கும் and loop direction வந்து opposite இருக்கும். So both are in opposite direction. So it is negative. So it is minus IR. Please take it. These are your four rules.
So what is the 100
What?
100 piece?
100 loop 100 T இல்லமா loop அது. Okay.
Yes, sir.
Okay. Right. So let's see next. So இதுல வந்து இப்போ நம்ம வந்து practically நம்ம டிஸ்கஸ் பண்ணோம். வோல்டேஜ் லா என்னது, வோல்டேஜ் லானா எப்படி இருக்கும் பார்க்கலாம். ரிமெம்பர் Kirchhoff's current law வந்து sum of all the currents is equal to 0 ன்னு சொல்லிட்டோம். Kirchhoff's current law என்ன சொல்லிருக்கேன், sum of all the currents is equal to 0 ன்னு சொல்லிருக்கேன். Kirchhoff's law வந்து sum of all the voltages is equal to 0. Remember it. Kirchhoff's voltage law வந்து sum of all the voltages is equal to 0. So voltage law related to your series connection. Okay, current law related எங்க branches இருக்கு அங்க வந்து current divide ஆயிருக்கு. இங்க series connectionல voltage divide ஆயிருக்கு. Okay, remember it. So நம்ம வந்து KVL எல்லாமே வந்து we will relate in terms of your voltage மட்டும் தான் நான் வந்து relate பண்றேன். Okay, so இதனால வந்து we know from the Ohm's law V is equal to IR. Even though there is a resistor, current flow ஆகுறதுனால I'll convert that relation in terms of your voltage only. Okay, எல்லா relations வந்து we have to write in terms of your voltage. Suppose ஒரு சின்ன example. Suppose ஒரு branch இருக்கு, நல்லா பாத்துக்கோங்க, ஒரு branch இருக்கு, அந்த branch மட்டும்தான் இருக்கு, அதுல resistance கிடையாது, just a connection. Current flow ஆகும், but there is no resistance. So when there is no resistance, we cannot able to take the voltage. Voltage வந்து இங்க 0 ஆயிருக்கும். Current flow ஆயிட்டு இருக்கு, இங்க வந்து resistance இல்லனா we cannot able to take the path. அந்த path வந்து we cannot able to consider it. அந்த path we cannot able to consider it because there is no resistance. And the resistance la current flow பண்ணாதான் there will be a terminal voltage across. Remember it. Okay, so always remember voltage law and சொல்லும்போது sum of all the voltage is equal to 0. அதோட summation வந்து series connection based பண்ணி தான் நம்ம டிஸ்கஸ் பண்ணோம். Okay, right. So இது ஒரு case. So let's see a சின்ன examples based பண்ணி போறோம். Is it over, ma? Have you taken it?
Yes, sir.
Let's see. Good. So let's see. First one. So சின்ன examples based பண்ணி போறோம். So I'll solve the circuit. சின்ன circuit இருக்கு. I'll solve with a direct method. Direct method உங்களுக்கு தெரிஞ்ச direct method நான் solve பண்றேன். And as well as I'll use the loop method also. That is your KVL. KVL also நான் யூஸ் பண்ணிட்டு solve பண்றேன். ரெண்டு equations சேமா இருக்கும், ரெண்டு solutions சேமா தான் வரும். அது எப்படி இருக்குன்னு பாருங்க. I'll take a small circuit here. சின்ன circuit பாருங்க. So நான் இதுக்கு முன்னாடி என்ன சொல்லிருக்கேன், series connection சொல்றேன். You can take series or parallel. It's up to you. So here I'll take a series connection circuit. Chinna circuit ko solranga. So I'm adding three resistors. I'll take this one as R1, this is your R2, and this is your R3. Mono resistance irukku. All three resistors are series connection. Yena same current flow aayirukku. So here across it I'm adding a voltage. Across it I'm adding a voltage. This is your voltage V. So the voltage. So plus terminal irukku, minus terminal irukku. There is a current flowing through the circuit. Current flow aayirukku R1, R2, R3. There are three resistors connected in series connection. Okay, let's see. So when we are discussing about the series connection, I know voltage on the divide agum solla. First we'll see the direct method. Direct method la adoda relation enna varum, equation enna varum. So currents on the R1, R2, R3 irukku. So here there is a voltage. Voltage across this will be V1. Here V2, and across the resistor it will be V3. Okay, so the terminal voltage, that is your supply voltage, என்ன ஆயிட்டு இருக்கு, மூணு different resistors split ஆயிட்டு இருக்கு because of the series connection. Current same ஆயிட்டு இருக்கும், voltage divide ஆயிட்டு இருக்கும். This is your series. So that means we can say V is equal to V1 plus V2 plus V3. It is simple circuit நால நான் வந்து டைரக்டா நான் வந்து find out. So we know that from the Ohm's law, what is V1? V1 is equal to I into R1, V2 is equal to I into R2, and V3 is equal to your I into R3. So in the circuit, I need to find the total current passing through it. Total current வந்து நான் find out பண்ணணும். So you can go with the equivalent resistance find out பண்ணிட்டு நீங்க பண்ணலாம். Or else நீங்க மூணுமே add பண்ணிட்டு நீங்க பண்ணலாம் from this relation like this. So V is equal to V1 என்னது I common இருக்குனால நான் separate R1 plus R2 plus R3. Okay, or we can say the relation as sum of all the voltage is equal to 0. That means V plus of minus V1 plus of minus V2 plus of minus V3, because in opposite direction it will be 0. Sum of all the voltage is equal to 0. Or in the equation I'll write it as the relation. I can write it as V minus I into R1 plus R2 plus R3 is equal to 0. So either on the, if I want, I can able to find the total voltage, or if I want, I can able to find the current also. So I is equal to V divided by R1 plus R2 plus R. This is the direct method. So you can able to solve it easily. This is the direct method. Okay. Suppose இதே method, I'll use the KVL. Loops base பண்ணி நான் எடுப்பேன். Loops வந்து clockwise னு சொல்லிருக்கேன், anti-clockwise னு சொல்றேன். ரெண்டு base பண்ணி we'll discuss. So after that, and remember, ரெண்டு இதுக்கு வந்து ஒரே equation தான் வரும். So you can choose whether it is clockwise or anti-clockwise, it's up to you. Let's see. Same circuit. I'll take the same circuit. I'll apply KVL. KVL loop law. So now the loop space பண்ணிருக்கேன். So first of all, I had to check whether the circuit is a closed circuit or not. இந்த circuit closed circuit. Current வந்து ஒரு பாயிண்ட்ல போயிட்டு இருக்கு, இன்னொரு பாயிண்ட்ல வந்து ரிப்பீட் ஆயிட்டு இருக்கு. இந்த closed circuit, இந்த சர்க்யூட்ல நல்லா பார்த்துக்கோங்க, இந்த சர்க்யூட்ல எத்தனை நம்பர் ஆஃப் காம்போனன்ட்ஸ் வேணும்னா இருக்கலாம். காம்போனன்ட்ஸ் மீன்ஸ் அது கம்பார்ட்மெண்ட்ஸ் மாதிரி. ஸோ இது ஒரு கம்பார்ட்மெண்ட், அதே மாதிரி இது ஒரு கம்பார்ட்மெண்ட், அதே மாதிரி இது ஒரு கம்பார்ட்மெண்ட். ஓகே, இந்த மாதிரி கம்பார்ட்மெண்ட்ஸ்ல இருக்கும்போது இண்டிவிஜுவல் கம்பார்ட்மெண்ட்ஸ் க்ளோஸ் சர்க்யூட் இருக்கா இல்லையா நான் செக் பண்ணேன். பட் இது வந்து சிம்பிள் சர்க்யூட்னால நான் வந்து காம்ப்ளெக்ஸ் பண்ண மாட்டேன். ஸோ லெட்ஸ் சி. ஸோ நான் வந்து லூப் எடுக்கிறேன். லூப் எப்படி எடுக்கிறேன்னா கிளாக்வைஸ் அண்ட் ஆஸ் வெல் அஸ் ஆன்டி கிளாக்வைஸ். ஃபர்ஸ்ட் ஐ டேக் த கிளாக்வைஸ் டைரக்ஷன். கிளாக்வைஸ் டைரக்ஷன் இந்த மாதிரி. ஸோ த ரெட் கலர் போர்ஷன் இஸ் நத்திங் பட் யுவர் லூப்ஸ். ஸோ ஏன்னா வந்து லூப் ஒரு பாயிண்ட் வந்து ஸ்டார்ட் ஆயிருக்கு, அகைன் சேம் பாயிண்ட்ல ரிப்பீட் ஆயிருக்கு. நல்லா பாருக்கும், ஒரு பாயிண்ட் வந்து ஸ்டார்ட் ஆயிருக்கு, சேம் பாயிண்ட் ரிப்பீட் ஆயிருக்கு. ஐ டேக் இட் ஆஸ் கிளாக் வைஸ் டைரக்ஷன். கிளாக் வைஸ் ரன் ஆயிருக்கு. லெட்ஸ் see that. ஸோ இதுல வந்து ரெசிஸ்டன்ஸ் R1 R2 R3. நான் வந்து 4 ரூல்ஸ் சொல்லியிருக்கேன். 4 ரூல்ஸ் என்ன சொல்லியிருக்கேன்? ஸோ கரண்ட் லூப் சேம் டைரக்ஷன் இருந்தா இட் வில் பி பாசிட்டிவ். இது மட்டும் மெமரைஸ் பண்ணிக்கோங்க. கரண்ட் லூப் சேம் டைரக்ஷன் தான் இட் வில் பி பாசிட்டிவ். ஸோ லெட்ஸ் see. So here it starts with the voltage. Now the Ohm's law formatல தான் நான் எழுதுறேன், which is equal to V is equal to IR. இந்த formatல தான் நான் equation எழுதுறேன். Remember it. So let's see. So இங்க வந்து it starts with the voltage. So voltage இருந்தா I'll take voltage V. Suppose voltage இல்லைன்னா it will be 0. Okay, அந்த மாதிரி தான் இருக்கு. So here there is a voltage which is equal to voltage loop current ரெண்டு same direction இருக்கிறதுனால so voltage is positive. Okay, voltage is positive, which is equal to your current flowing through the resistor R1. So current flowing through the resistor R1. So current loop both are in the same direction. So it is positive. So I into R1. And inge same current resistance loop in the same direction. Current loop both are in the same direction for the resistance R. So it is plus I into R2. And here also current and loop both are in same direction. So it is plus I into R3. So which is equal to now on the I common at the it is R1 plus R2 plus R3. So from this equation, I can able to find the current. So I is equal to V divided by R1 plus R2 plus R3. Okay, this is your relation with the help of your clockwise loop direction. Okay, we see the relation. Okay, depends upon the direction based on the equation. ஒரே ஒரு compartment இருக்கு, ஒரே ஒரு closed path இருக்கிறதுனால ஒரே ஒரு equation தான். So if you see that இது ரெண்டும் சேம் தான். இது direct method, இது வந்து KVL, indirect method னு சொல்லலாம். So now what I'll do, second case, I'll take anti-clockwise direction. I'll take anti-clockwise direction. So with respect to the anti-clockwise direction, the relations எப்படி இருக்குன்னு பார்க்கலாம். Okay, so in this case, now இதே loop, I'll remove it. I'll take anti-clockwise. Anti-clockwise. So it starts from negative and it trends to the positive. So this is your anti-clockwise direction. Anti-clockwise. Anti-clockwise. Now we'll see the relation for the anti-clockwise. So directions on the opposite direction, it will be negative on solution. First, we'll start with the voltage. Voltage current and the loop direction both are in opposite. So it is your minus V is equal to. So here on the current for R1, current for R1 and as well as your loop both are in opposite direction. Let's see, both are in opposite direction. So loop in the direction. Okay, current and your loop both are in opposite direction. So it is a minus I into R1. And same thing, current and loop for the resistors both are in opposite. So it is I into R2. And for the resistance R3 also it is minus I into R3. So minus 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 will get cancelled. So V is equal to I into R1 plus R2 plus R3. Or current I is equal to V divided by R1 plus R2 plus R3. So we can take either way. So equations correct. Simple circuit we can go with the direct method. Complex circuit, we can go with the KVL. By taking the loops, we can solve. Okay, please take it. This is doubt in the KVL. Just for example, so a complex circuit, we'll solve it. Please take it. This is doubt in the KVL.
So why can't we use KVL for simple circuits?
Why can't we use? We can use it. If you are comfortable, we can use it. ஒரு சின்ன சர்க்யூட் வந்து நான் பார்த்த உடனே ஆன்சர் பண்ற மாதிரி இருந்தா why will I use this loop? By seeing itself I can able to give the answer within seconds. Complex circuit வந்து it is bit possible, it is not possible. So for that I'll take the use loops, I'll cancel it out, I'll find the currents. புரியுதா உங்களுக்கு? Now we'll solve the circuits, no issues. இப்போதான் ஸ்டார்ட் பண்ணோம். We'll solve the circuits. What? Right. So let's see ஒரு சின்ன circuit பார்க்கலாம். So in this circuit, we'll take a closed loop or a சின்ன loop எடுத்துட்டு we'll try to solve. Okay. What I'll do, I'll display the PDF, then we'll take it. One bit, I'm just taking the circuit. Okay. Is it visible now? Now, is it visible? Yeah. So question number 156, NCERT question. Okay, 156. Now, can you able to solve this circuit? Question பார்த்துட்டு I'll read the question, I explain பண்ற question, then we'll solve it. Direct method base பண்ணி போலாம். Suppose if we can able to solve it without loops, we'll solve it. Or else நம்ம வந்து loops base பண்ணி we'll solve it. Here itself I'll solve it, the question. So let's see, the question is network PQRS is made under PQ has a battery 4 volts. This is your PQ part. And negligible resistance with a positive terminal connected. So there is no resistance for this voltage. And they have given the branch currents also. Yellow direction of branch currents and so identify பண்ணிட்டாங்க. Suppose the circuit lo vandu if there is no directions, நல்லா பாத்துக்கோ, if there is no directions, current and சொல்லிட்டு directions சொல்லிட்டு எதுவுமே கொடுக்கலனா, you have to apply your KCL and you have to select the current direction. Current direction select பண்ணதுக்கு அப்புறம் தான் you have to apply your KVL. Remember, KCL apply பண்ணிட்டு loops directions கொடுத்ததுக்கு அப்புறம் தான் you have to apply KVL. Okay, இல்லனா என்ன ஆகும், suppose current directions இல்லனா you cannot able to take the equations also. Okay, remember. So in this case, so here if you see that இதுல வந்து இது closed circuit தான், நல்லா பாத்துக்கோங்க, இது closed circuit தான். இந்த closed circuitல வந்து total circuit இது. Okay, but இங்க வந்து divide பண்ணதுனால two different compartments are divided. So I'll take this one as first compartment, I'll take this one as second compartment. Suppose இங்க வந்து இன்னொரு resistance இந்த மாதிரி parallel add பண்ணாலும் I have to take this as third compartment இந்த மாதிரி. Okay, 1 2 3, there are three different compartments. Let's see, one man will discuss. In this case, question lo, so here calculate the readings of milliammeter. Calculate the readings of milliammeter. I need to find the currents. So that is passing through 20 ohms. So here this is your 20 ohms. I need to find the current. That is your I1 now on the find it. Okay, remember question on the I need to find I1. Let's see the relations here. This already avangale வந்து loops எடுத்துட்டாங்க. So loops, it is loops in clockwise direction. Okay, ரெண்டு loops in the clockwise direction எடுத்துட்டாங்க. I'll take this one as first equation, I'll take this one as second equation. Two equations வருது. Condition another, here it should be closed circuit. Suppose இதுல வந்து ஏதாவது ஒரு switch open ஆயிருந்தா current flow ஆகாது. It should be closed circuit and it is your closed circuit, and here ரெண்டு compartments இருக்கு. ஒரு compartment ஒரு loop இருக்கு, இன்னொரு compartment இன்னொரு loop இருக்கு. Okay, right, clear. So there are two equations for you. Let's see the first equation. First equation வந்து I'll start with the voltage. நான் வந்து voltage base பண்ணி start பண்றேன். இதுல voltage base பண்ணி நான் ஸ்டார்ட் பண்றேன்னா here if you see that voltage வந்து எவ்வளவு voltage இருக்கு, 5 volts இருக்கு. And நல்லா பாத்துக்கோங்க, current it is in opposite direction. Remember, இது வந்து நெகட்டிவ் இருக்கு, இது பாசிட்டிவ் இருக்கு. Okay, loop வந்து ஒரு டைரக்ஷன் இருக்கு, current இதுல flow ஆகுற current வந்து opposite இருக்கு. Let's see that. Equation வரும்போது when you are taking the clockwise, இது opposite direction இருக்குதுங்களா, to the current is opposite direction, so it is minus 5 volts. Minus 5 is equal to, I'm discussing about the first loop 1. The doubt is not stop on it. I'm just going in a sequence. I'm going. Okay. So which is equal to voltage in the opposite direction, it will be negative. And in the loop current both are in same direction to the resistance. Loop in the same direction and current is also same direction. So the voltage for this resistor, it is R into I. So IR is nothing but your voltage. So 200 into I minus I1 per point. So இங்க இதே லூப்க்கு இன்னொரு ரெசிஸ்டன்ஸ் வந்து லிங்க் ஆயிட்டு, ஸோ இந்த ரெசிஸ்டன்ஸ் வந்து இந்த லீக் ஆயிட்டு இருக்கிறதுனால ஸோ இங்கே வந்து கரண்ட் வந்து I1 ஆப்போசிட் டு த லூப் டிராவல் இருக்கு. ஸோ இட் இஸ் அ மைனஸ் 20 I1. இது ஒரு வோல்டேஜ், இது ஒரு வோல்டேஜ், இது ஒரு வோல்டேஜ். ஸோ இட் இஸ் நத்திங் பட் யுவர் KVL. ஸோ வோல்டேஜ் பேஸ் பண்ணி தான் டிஸ்கஸ் பண்ணுறோம். ஸோ I'll take this one as first equation. Okay, let's see the second loop. Second loop வந்து I'll start with the voltage. So 4 volts loop current both are in the same direction. 4 volt is positive. 4 is equal to, so it is like linked to the 20 ohms resistor. In the loop on it is linked to the 20 ohms resistor. And remember on the branch ku enna current flow aayirukku, and the current mattum dhaan edukrom. Okay, remember inge branch ku I1 da flow aayirukku, both the loops I1 mattum dhaan poitirukku. Here both are in the same direction, so it is a 20 I1. And inge flow agra current on the I irukku, and both are in the same direction. So loop and current both are in the same direction. It is a plus 60 I. This is your second equation. Remember, idhula edha doubt irukka, first just try to understand to write the loops based panni equations note பண்றது practice பண்ணுங்க. After that you can do practice your equation solving. Okay,
sir, the arrow mark represents the loops, sir.
yes ma, that circle is there, right? This is your loops. Clockwise எடுத்திருக்காங்க, அவங்களே क्वेश्चन கொடுத்துட்டாங்க clockwise. Okay, upper part I had taken it as first loop, lower part I had taken it as second loop. அது பேஸ் பண்ணி நான் equations நோட் பண்ணிட்டேன். இப்போ நான் இது சால்வ் பண்ணிட்டு I need to find the current I1. That is your question. இந்த மாதிரி டிபிக்கலா இருக்க சர்க்யூட் நான் டைரக்ட் மெத்தட் சால்வ் பண்ணா it will take more time. Instead of that we are taking the loops. Let's see that நான் இது சால்வ் பண்றேன். For that what I'll do, I'll just cross multiply பண்ணிட்டு I'll do it. So here it is minus 5 is equal to 200I minus 200I1 minus 20I1. So which is equal to minus 5 is equal to 200I minus 220 I1. So in the equation, first equation. In the equation, I have to solve with a fourth. So 4 is equal to 20 I1 plus 60 I. It is your second. For that, what I'll do now, this cancel agumon na check panna. So in the first equation, what I'll do, I'll divide by 5. So I divide by 5. When I divide by 5, minus 1 is equal to, it is 4 5 20. So it is 40 I minus 44 I1. Okay. So இது வந்து 5 ஓட டிவைட் பண்ணா I'll get this relation. Okay. And இங்க வந்து என்ன ஆகும்னா it is 4 is equal to, it is a 20 I1 plus 60 I. Okay. This is your relation. Now, இப்போ நான் வந்து மேட்ச் பண்ணணும். மேட்ச் பண்ணாதான் கேன்சல் பண்ண முடியும். So for that, what I'll do, I should match. So in the matching நான் என்ன பண்றேன்னா, I'll try to cancel 40 I term வந்து நான் cancel பண்ணா அப்போதான் எனக்கு வந்து I1 வரும். So for that, what I'll do, I'll multiply by 2 here. So first equation I'll multiply by 2. Second equation I'll multiply by 3. Okay. Okay. So இங்க வந்து when I multiply it, what will happen? இங்க வந்து it is 120 I. Okay. So the relation will be, it is sorry, இது 3 ஓட multiply பண்றேன், இது 2 ஓட multiply பண்றேன். First equation 3 order, second equation 2 order. So when I do it, it will be minus 3 is equal to, it is 120 I minus, it will be around 44 into 3 times, it will be minus 132 I1. 2 times 8 is equal to, this is 40 I1 plus your 120 I. So now I'm going to subtract. When I do subtraction, both the equations, it is a minus, it will be minus and it will be minus. Okay. So then now minus 120I and 120I will get cancelled. So it is a minus 3 minus 8. It will be minus 11. I'll write here itself. It is minus 11, which is equal to. You got the minus 40 I1 minus 132 I1. So it will be minus 172 I1. So minus minus will get cancelled. So I1 is equal to your 11 divided by 170. To solve it, you'll get approximately 0.064 amps. This is your current I1. So first equation solve பண்றது note பண்ணிட்டீங்கன்னா, then we can able to solve the currents, then we can able to find it. Just இப்போதான் நம்ம வந்து start பண்ணிருக்கோம், அதனால it will take time. So next classல வந்து we'll do some more problems. Note பண்ணிக்கோங்க.
அப்போ இது வந்து சீரிஸா சார்? சீரிஸ்
எதுமா சீரிஸ்?
இது வந்து KVL தான் சார்.
நான் சீரிஸ் எதுக்கு சொல்லிருக்கேன்னா, இங்க பாருங்க, when you're taking the loop, the whole loop should be in series only, correct? அப்பதானே அந்த வோல்டேஜ் எல்லாம் நான் வந்து ஆட் பண்ண முடியும். அது நான் ஆட் தானே பண்ணிருக்கேன் எல்லா வோல்டேஜஸ், கரெக்ட்டா? இங்க ஒரு வோல்டேஜ் இருக்கு, across this there is a ohms law, v is equal to r, across this there is ohms law. எல்லாம் மூணு ஆட் பண்றது தான் அது வந்து KVL. அவ்வளவுதான். புரியுதா? Right. So if you want, you can take the screenshot. Okay. So till this is enough. So next class we will do practice. So there are so many loops are there, so many equations, circuits are there. Step by step number solve. Okay. Till this, any doubts? So for you, just solve your series and parallel circuits. Textbook la irukka ella series and parallel circuits solve பண்ணுங்க. Doubt in you can ask me. Okay. Okay, ma. We'll see you next class. Thank you.